So, what is kinematics? Who can tell me what is kinematics? Is there anybody in this class? Yes, please, go ahead. What is kinematics?
Kinematics is the study of the motion of an object without reference to force.
Okay, very good. That's very good. You have said that motion. What is motion? Motion means change in position. Change in position of an object. Motion is change in position of a body. Whenever a body changes its position, the body has moved. If this is a reference plane, and this is the origin, you were here originally, point x1. You have been here at point x1 with respect to the origin. For instance, I am a distance away from this wall. I'm a distance away from this board. The board becomes my reference, or the wall becomes my reference. So, this is you, this is me, standing here with respect to the wall, or with respect to the board. This is my position. If I don't leave where I am, it means there is no motion yet. So anytime I change, this is where I am, x1. This is my position from here to the origin, reference point. If I change my position to point what? x2, my position from the origin is now x2. From here to here is now x2. Because I have changed, I have moved from here to here, I've changed my position from 1 to what? To 2. There is motion. Motion is change in position of a body, an object, of a body or of an object. What are the types of motion? Types of motion. We have linear or translational motion. Types of motion is your writing. Linear or translational motion. What type do we have again? What are the types of motion you know? Who is telling me? Oscillatory motion. God bless you. Oscillatory motion. Oscillatory motion. You can give me another one. Random motion. Random motion. So the types of motion. You can give me another one.
Rotational motion.
Rotational motion. Rotational motion. These are the types of motion. Who can give me another one?
Relative motion.
I can't hear you.
Relative motion.
No, that's not a type of motion. Relative motion is not a type of motion. No. Relative motion is not a type of motion. Okay, another one. Anybody? Who can give me another type of motion? Okay. Since you're not giving anyone, you should know that what? These are the only 4 types of motion. Any other motion you have in your head falls under here. If it's not linear, it will be oscillatory or random or rotational motion. There are 4 types of motion in physics. Any other motion you mention will fall under one of these 4. So what do you call linear or translational motion? Anybody? What's linear or translational motion? Anybody?
It's the type of motion in which when an object from point A to point B, when the person in point A moves to point B without any direction, like you move in linear.
Yeah, you tried. Just tell me the linear motion or this motion is motion of a body on a what? On a straight line. Motion of a body on a what? On a straight line. That is linear motion. It's a motion on a straight line. E.g., going from your house to school is a linear motion. Going from your house to school is a linear motion. It's a motion on a straight line. Any motion on a straight line is called translational or linear motion. Then I will go to the next one. Who can tell me what is rotational motion? Anybody? What is rotational motion? What is rotational motion? Anybody?
Motion about a fixed point.
Good. It's a motion of a body. It's a motion of a body about a fixed point. It's a motion of the body about a fixed point. A fixed point or a fixed axis. Or a fixed axis. Who can give me an example of rotational motion? Examples of rotational motion. Sorry? Yeah, motion of the blades of a fan. Motion of the blades of a fan. Now, when a body rotates, when you say a body rotates, what it means is that the motion of the body or the body does not translate. The body does not change its position. The body does not change its what? Position. Anytime you say you have rotational motion, the body does not move from one place to the other. There is no change in what? Position. The blade of the fan does not leave the wheel. Okay? It stays there and rotates. Actually, it's the wheel that rotates the blade. Okay? So that in that case, the blade will never leave the engine. The rotational motion there is the wheel of the fan. Is the engine, the fan that actually what rotates. The rotor is what that rotates, not really the blade. But because the blade is not changing its position, the blade is rotating. The tire of a car also rotates. The tire of a car also what? Rotates. Why? It does not leave that place. The tire does not leave where it is. Okay? Now, there's a difference between rotation and what? And rolling. Who can differentiate between rotation and rolling? Who can differentiate between rotation and rolling? Anybody that wants to understand rotational motion must also understand what? Rolling motion or a body rolling. There's a difference. Who can tell me the difference?
In rotation now, the point is fixed. But in rolling, the position changes.
That's good. That's good. For rotation, you rotate or you move about a fixed point. You don't live where you are. You don't live where you are. But for rolling, the body rotates. Rolling involves rotation plus translation. Please take note of this. Rolling involves what? Rotation and what? Translation. If you see this marker, watch. If I spin this marker, watch. What do you have? If you spin it, the marker will do what? A roll. If you leave this marker to come down, it will do like this. You roll, and do what? Come down. If you lift a ball on an inclined plane, this is an inclined plane, you put a ball here. What does the ball do? The ball rolls down. The ball will what? Roll. You can see it will roll. it will roll down. That is what is rolling. But as the body is rolling, it's also translating, meaning it's going from one point to another. Like the girl said, from point A to point what? B. That is translational motion. What the girl said that time. What she said that time. You go from point A to point B. That's translational already. But the body here roll to get here, meaning it rotates and what? Translates. In summary, rolling involves what? Rotation and what? Translation. If you put another object on this inclined plane, but it's a flat or rectangular object like this will slide on the inclined plane. It will not roll. No, it will not roll. It slides. It will slide on the inclined plane from point A to point B. In this case, we say this is translating. This is translating. But for a board on this, the board will roll down. To roll down the inclined plane. To roll down the inclined plane. You can see. The board rolls down the inclined plane. It will roll down the inclined plane. This is rolling, but here we only slide down. This is translation. So take note of that. That rolling involves rotation and translation. The body rotates and also change its position. In rotation, the body only moves about a fixed point. What do you call oscillatory motion? Anybody? What is oscillatory motion? Anybody?
Oscillatory motion as a flow of the body about the fixed point.
Come again. Say it again.
Oscillatory motion can be defined as a to and fro of an object about the fixed point.
Okay, the to and fro motion of an object about a particular point. That means the body is moving to and fro of a particular fixed point, meaning it can exceed a particular region. For instance, if you have, how do I put it? If you have snooker balls, the snooker balls, they move to and fro that place, but they will not be able to go out of the board. Okay? If you have, let's say we have ball rings, some small balls within this confinement. The balls are moving with this confinement within here. They can only go to and fro, but they will never escape this boundary. They can only move to and fro. Oscillatory motion is what? To and fro motion of a body about a particular point. Exactly. There must always be a reference point of motion. Okay? And for oscillatory motion, what do you have? Example is the what? Motion. Example is the motion of the ball. Motion of the ball. Motion of the ball of a pendulum. The ball of a pendulum swings to, fro, about a fixed point. About the fixed point. This fixed point here, which is called the equilibrium position. It goes here, returns, it goes, returns. At the end of the day, when the ball starts moving, it stands here. When it's not going to and fro, it will stand here. The point where it starts, when it stops moving, is called the fixed point we're talking about. So the distance traveled we measured from here to here, or from here to here. Not from here to here, no. It goes to, fro, to, about this fixed point. That is oscillatory motion, or the to and fro motion of the body. Okay? The last type of motion is a random motion. Who can tell me, what do you call random motion? What is random motion? What is random motion?
So I already have an idea of it.
Okay, please say it.
Like for example, if you are traveling, the way trees are always like the trees like the other. When we are moving, we're coming towards was so it's the opposite. But I don't know how to do it.
Okay. Okay. Wait, you want to try? You have tried. Randomness is what? We call it what? Irregular motion. It's irregular motion or motion that is in haphazard manner. Motion in haphazard what? Manner. Motion that is irregular. It can be any of these. It can be rotational, it can be translational, it can be what? Linear, it can be whatever. It's just irregular. It's not in a particular fashion. It's haphazard. It's in irregular manner. It's random. Meaning, random means what? It can be anyone. I mean, when you say random, pick something randomly. You don't know what you're doing. I mean, you're picking. Is that okay now? Random can be any type of motion. So we say random motion is an haphazard motion, regular motion of a what? A body. Example is what? How the pollen grains, how it moves inside water. It's haphazard. We don't know how it does. The smoke. How does smoke move? You can't detect the direction the smoke moves. Smoke moves anyhow. It moves anyhow. That's called what? Random motion. Motion that does not have a particular word, direction. Like the girl said, she did not know how to explain it, which means the motion is haphazard. The motion is irregular, is random. These are the examples of motion. So let's see some terminologies in motion. Let's see some terminologies in motion. You have seen the types of motion and the examples of the types of various examples of the motion. So let's see the terms that we use in motion. Terminologies in motion. The first thing is position, which can be X, Y, Z, or R, as we like. Position can have symbol S, Y, Z, or what? Or R. So what is position? Who can tell me what is position? Anybody? Who can define position? Can anyone define position? We have said motion is a change in the position of a body. We are doing terminologies now. I ask you, what do you call position? Anybody? What is position? Anybody?
Position of an object is a physical location in space related to an object or other reference point.
That's good. That's very good. In fact, you got 10 over 10. It's 10 over 10. Because you mentioned all the ingredients of position. You mentioned everything about position. Position is what? Instantaneous location. Is instantaneous location of a body. Of a what? A body with reference to an origin. Is the instantaneous location of a body with reference to an origin or to a reference plane. You must have a plane of reference. You must have a location, an origin where you measure from. I'm here now. I'm here. What is my position from the board? Meaning, my position is my location with reference to this board. There must always be a reference. So, position is given as X equals a function of time. It can be Y equals a function of time. It can be Z equals a function of time. It can be R equals a function of time. It's an instantaneous location. When you know the word instantaneous, it means it's the location at a particular time. It's the location of a body at a particular what? Time. That's the meaning of what? Of instantaneous. Meaning, at this time now, I am here with reference to this board. What's the time now? Maybe 9:20. I am here now with reference to this board. You snap me. This is my location at the point you snapped me. When you snap me next, maybe I will be here at another time. I've changed my location. But my location here, my instantaneous location, meaning my position at this time, is from here to the board. You can measure it. So it's a function of time. It's a function of time. Right, example, right, example. Right. Right. The instantaneous position of a body is given as x equals, I could say x, I could say y, I could say z, I could say r. I'm free to say anything. It's given as x equals 2t squared minus 2t plus 1. 2t squared minus 2t plus 1. Where x is in meter and t is time in seconds. Where x is in meters and t is time in seconds. Where s is in meters and t is time in seconds. And x is measured with reference to the origin. And x is measured with reference to the origin. Full stop. Determine the position of the body. Determine the position of the body at 1, t equals 2 seconds. 2, t equals 3 seconds. Here fast, do it and give the answer. Tell me the location, position of the body at time t equals 2 seconds, t equals 3 seconds. Do not forget that your position is a function of time. Where you are is a function of time. Where are you at time t? Where are you at time t? That is your location. That's your position. So when t is 2 seconds, where are you? When t is 3 seconds, where are you? That's, you are finding your distance from the origin. You are finding distance x from the origin at a given time t. That's what you are finding. Yeah, fast. When t is 2 seconds, where are you in class? Tell me.
5.
Say it where? X equals, what do you mean by 5? Tell me like a year 1 student, an A-level student. When t is 2 seconds, where are you?
3 meters, sir.
Where are you when t is 2 seconds? Where are you? You put t as 2 in this formula. So you have x equals 2 into 2 squared. I'm putting t as 2. T as 2 minus 2 times 2 plus 1. So x equals 8 minus 4 plus 1. So x equals 5 meters. Who can interpret this answer? What does the 5 meter mean? Say it when it should be said. What does the 5 meter mean? I can't hear you.
5 meters from the origin.
You will say the body is positioned 5 meters from the what? Origin. The body is positioned 5 meters from the origin, from the reference plane, from the origin. That is what I want you to say. This is what I want you to say. The body is positioned 5 meters from the origin. When time is 3 seconds, where is the body positioned? When time is 3 seconds, where is the body positioned? Class, talk to me.
The body, the position of
The body is positioned what? 13 meters from the origin. I love that. So put t as 3. We have x equals 2 into 3 squared minus 2 into 3 plus 1. All I do is to put t as 3 in this equation. T is 3 for number 2. T is 2 for number 1. So put t as 3. That's 2 times 3 squared minus 2 times 3 plus 1. 3 squared is 9. That's 2 times 9 minus 6 plus 1. This is 18 minus 6 plus 1. And that's what? 13 meters from the origin. From the origin. 13 meters. And the body is positioned 13 meters away from the origin. Did you get this in class? Talk to me, class. Talk to me.
Yes.
Good. What's more important is presenting, is saying from the origin. What is more important? By saying from the origin. From the origin. Very important. Or from the reference plane. Very important. Let's go to number 2. Second time, we have explained position. And I've told you, watch, class, watch. Position can be X, can be Y, can be Z, can be R. When can it be R? It can be R when you are given, it can be R when you are given both X and Y. You now say R is XI plus YJ, or R is XI plus YJ plus ZK. It can be any of these, and it can be S. You can say S is 2t squared minus 2t plus 1. Instead of using X, Y, Z, they can use S. They can use R. When is R used? Anytime they give you S and they give you Y, you can use what? R. Let me test this. Question number 2. Right. Question number 2. Question number 2. A body undergoes two-dimensional motion. Undergoes two-dimensional motion with the following position vector. Sorry, with the following positions. With the following positions. Right. X equals t squared minus 3. And y equals 3t squared minus 2t minus 1. Where x is instantaneous, where x is instantaneous position along the x-axis, and y is instantaneous position along the y-axis, Full stop. Determine its position after 2 seconds. In unit vector notation and in magnitude notation. Now, watch it. Don't be scared. In example, I can give you a page for question. The answer is just a line. The answer is a line. Now, who can solve this? I'm waiting. You have to find us position in unit vector notation and in magnitude notation I've told you already that after vector and unit and dimension, we'll now start applying. We'll start what? Applying. So we are applying this now. We are applying vector, we have let before, here now. So what do you do? Okay, let's solve it. Look up everybody. Anytime you are given position, they give you position along X, along Y, or even along Z. This is what you must use, R, and not X, not Y, not Z. You just say R, vector R is XI plus YJ. Take note of that. If it is X, Y, and Z they give to you, you will say R is XI plus YJ plus ZK. If you are given X, Y, and what? Z. If you are given only X, like what I did before, only X, or only Y, or only Z, or only S, like this, just do your thing. You have done it before. But if you are given 2 dimension, this is a 2-dimensional motion. It's 2D. It's 2D, meaning you have S and what? Y. If you have 3D, you have Z. You have S, Y, and Z, or you have S and Z, you have Y and Z. That's 3D. So this is 2D. My R is just, please class, tell me, what is our X? What's the X they give to us? T squared minus 3. This is the X they give to us. I mean that. Plus, what's the Y they give to us? What's the Y they give us? 3t squared minus 2t minus 1 J. This is the equation. But at what time are we working? At what time are we working? At what time?
2 seconds.
2 seconds. So when t is 2 seconds, t is 2 seconds. Where is what's now r? R is now, it means put t as 2. If you see t anyway, put it as what? 2. Let's do this. This is now 2 squared minus 3. Don't forget your I. I means this value is along x-axis. It means it's a position along what? X-axis. That's the meaning of I. Plus bracket 3. What's the t again? 2 squared minus 2 times 2 minus 1. And put what? J. J means that what? This position you are getting is a position along y-axis. Good. At the end of the day, please, what's 2 squared? 4 minus 3. Then put I. Don't forget your I. Plus 2 squared is what? 4 times 3, 12. 2 times 2, 4 minus 1. Don't forget your J. Your J means this value is along y-axis. So final answer, this I plus 12 minus 4 minus 1. That's 7J. This 7J. This is our R. Our R in unit vector notation. Our R in unit vector notation is what? I plus 7J. Who can interpret this answer? Who can interpret this answer? That means at time t equal to 2 seconds.
1 unit to the x-axis and 7 units to the y-axis.
Come again.
1 unit to the x.
Don't say 1 unit. Say 1 meter. 1 meter.
Okay, 1 meter.
1 meter to the what?
To the x-axis and 7 meters to the y-axis.
God bless you. God bless you. That's nice. So the body is positioned. The body is positioned 1 meter to the x-axis, 7 meters to the y what? Positive y-axis after 2 seconds. This is position in 2 seconds. And this answer is in unit vector notation. This answer is in unit vector notation. Because we have I and J there. Let's now see the answer. What will be the answer in magnitude and direction notation? In magnitude notation. In magnitude notation. Magnitude notation. Your R is I plus 7J. You are finding the magnitude of R. How do you find the magnitude of a vector? Anybody? How do you find the magnitude of a vector? I've taught you all this.
Square root of RX squared plus RY.
Thank you. So in this case, what's here? 1 square plus 7 square. God bless you. This is 1I, so 1 square. This is 7J, 7 square. And that's what? Square root of 50. Am I correct?
Yes, sir.
And that's 5 root 2 meters. Let's go to the next term. Which term have we explained here? Which term?
Position, sir.
God bless you. Let's go to term number 2. Term number 2. Term number 2. Number 2, the second term. The second term is displacement. Is displacement, which we can call change in x. If it's x we are using, which is what? x2 minus x1. Change in y, if it's y we are using, y2 minus y1. Change in z, if the symbol is z, z2 minus z1. Or change in s, if it's s we are using, or change in r, if it's a mixture of s, y, z. If you have a mixture of s, y, z, we use r. This is what explains when to use r. When they give you positions along x, along y, we go for r. We don't go for any of these. So what is displacement? Displacement means change in position. Change in position. That's called what? Displacement with respect to an origin. Displacement means change in position with respect to an origin. This is position at time t1. This position at time t2. This position for along y at time t1, and so on. Displacement just means change in position. When you were here, it's change in position with reference to an origin or a reference plane. This is reference plane. This is 0. You were here at time t1. Your position is this, x1. At time t2, your position has now moved to s2. Technically, you have moved from here to here. You have moved from here. This change in s. This change in s. You were here before at time t1. You are now here at time t2. This is a change in position. We can say x1 plus delta s equals to s2. Do you agree that this plus this is this? Confirm to me. Is that clear?
Yes, sir.
Yes, sir.
This
Yes, sir.
plus this is all of this. This is a change. You were here before, now you have moved here. You are now here. Your position is always with reference to the origin. Your position is with reference to the origin. By how much has your position changed? It has changed from here to here. And that's delta S. So this plus this is all of this. That's why delta S is x2 minus x1. That's delta S. x2 minus x1. That's what I do all this. All this. Right. Take note. Right. Question. The instantaneous position of a particle the instantaneous position of a particle with respect to the origin is given as S equals t squared minus 2t plus 3. T squared minus 2t plus 3. Full stop. Determine the change in position of the particle. Determine the change in position. Determine the change in position of the particle in the time interval t1 equals 2 seconds and t2 equals 3 seconds. Determine the change in position of the particle in the time interval t1 equals 2 seconds and t2 equals 3 seconds. That's the question. Yeah, fast. Attempt. What is the change in position? Change in position means displacement. These are our way of saying find displacement. Find displacement. Do that for me fast.
So what's the value of T1?
Sorry?
What's the value of T1?
2 seconds. And T2, 3 seconds.
Change in position is 3 meters.
3 meters? No,
Yes.
that's not 3 meters. Yeah. Good. So let's see. Our S is t squared minus 2t plus 3. So when t1 is 2 seconds, when t1 is 2 seconds, we're going to find S1. When t1 is 2 seconds, we'll find S1. When t2 is 3 seconds, we're going to find S2. And our displacement is what? Delta S. Change in position is S2 minus S1. So let's get S1 by putting T as 2. What was that? 2 squared minus 2 times 2 plus 3. That will be what? 4 minus 4 plus 3. Answer is what? 3 meters. That means at time 2 seconds, the particle is 3 meters from the origin. Then for S2 now, when T is 3 seconds, put 3 seconds here. Abina, so you have what?
Yes, sir.
3 squared minus 2 times 3 plus 3. I put 3 seconds here. I first put 2 where I saw T here. I got 3 meters. Now I'm putting 3 where I see T. And I'll get what? What's 3 squared? 9. 2 times 3, 6 plus 3. What's the answer? 6 meters. Is that correct? Is that correct?
Yes, sir.
So displacement or change in position is S2, which is 6, minus X1, which is 3. Answer is 3 meters. That's a change in position. That's a change in position. Are you guys following me?
Yes, sir.
Good, good. So let's see the third term. The third, number 3 term. I will stop there for today. Number 3 term. That is velocity. Number 3 is velocity. So, velocity? Anybody?
Velocity is the rate of change of displacement in time.
Good. Good. Velocity is simply what? Displacement all over what? Time. Is displacement over time. That's what velocity is, the rate of change of displacement to time. Rate of change of position to time, or displacement towards time. Good. Now, if you say rate of change to time, it is not tautology. You can have rate of change to displacement, to distance. You can have rate of change to anything. For instance, this is what? dv dt. This is rate of change of volume to what? Time. You can have dv ds. This is rate of change of volume with respect to x. Rate of change does not always mean time. Rate of change can be with anything. If I give you the volume of a cell as 4 pi r cube, I can find dv dr. This is the rate of change of volume with respect to radius. I'm saying this because some will say, I said rate of change of position to time. They will say rate already mean time. No. Rate doesn't mean time or only. Rate means many things. Good. Your velocity will be in 3 places. We'll start with average velocity. Average velocity. What is average velocity? What is average velocity? What is average velocity? Is the what? Is the velocity over a time interval. Velocity over a time what? Interval is called what? Average velocity. The velocity of the body over a time interval, like T1 and T2, is called average. Velocity of the body obtained over a time interval is called average velocity. And that's what? Your displacement over what? Time. Is your what? x2 minus x1 over t2 minus t1. This is average. This is average. This is average. Your velocity over a time interval. If it's not x, it can be y. It can be z. It can be what? r. It can be anything. But this is your average velocity. Velocity over time interval. What is that again? We have average speed. We have average speed. What is average speed? Take note. It's total distance traveled. Average speed is total distance traveled all over total time taken. Over total time taken. That's average speed. That's average speed. Average velocity is a vector quantity. Average speed is a scalar quantity. These are things I want you to know. Average velocity is a vector quantity. Average speed is a scalar quantity. And we have the last one under velocity. We have instantaneous velocity. Instantaneous velocity. Instantaneous velocity. What is instantaneous velocity? Is, as the name implies, instantaneous. At an instant, at a particular time, is the velocity at a particular time, and is obtained from limits of change in s over change in t, as change in t tends to 0, and is simply given as ds dt. Take note, is the limit of average velocity. If you find the limit of average velocity as change in time tend towards 0, if you find the limit of average velocity as change in time tends towards 0, you will get instantaneous velocity, ds dt. What is instantaneous velocity? Is the velocity at a particular time, which means no change in time, a singular time at time t. What's average? Between time interval. What's instantaneous? At a particular time, singular time. You can see we said change in time tends to 0, which means T2 minus T1 tends to 0, which means T2 tends to T1. No change in time. If T1 is 2 seconds, then T2 should be tending towards what? 2 seconds also. No change in time. Are you following me at all? Are you following me?
Yes,
Very good. So we'll continue from here in the next class. We'll continue from here in the next class. That means in the next class, you remind me I'm to start examples on velocity. Who will do that? Who will do that?
I'm going to do that, sir.
God bless you. That's Pfizer, me. Pfizer.
No, talk for me.
Talk for me. Good. So talk for me, you tell us on Saturday.
No, sir, it's not me, but I'm here actually.
Okay, good. Good. So talk for me, Pfizer will remind you on Saturday to continue from this place. Alright, so I will send a video of the class to the group also. I will send a video. Have a good morning. Thank you and bye.